Hi there, my name's Martin. Here is an overview of Diffusion version 6.6, the vision and key capabilities. With this release, we are introducing a new name, Diffusion Intelligent Event Data Platform, comprising 3 key components. Let me briefly introduce you to each. Firstly, there's Data Gateway, which facilitates the consumption of data from a variety of sources and in disparate formats, and publishing the processed event data into the Diffusion platform. Data Gateway includes adapters to connect with a variety of data sources. The vision for Data Gateway includes capabilities for transformation of formats, computation to add business logic, and more. Data Wrangling comes next, where the topic tree structure can be designed and access controls assigned to route the event data for further distribution. These activities can be performed via the management console or the SDKs. The Data Wrangling component has a rich set of capabilities to dynamically transform your event data, as well as the topic tree design. And then comes the data distribution component, which is where Diffusion achieves massively scalable transmission of event data around the world in milliseconds, with secure access control to assure reliable delivery of the exact data in the correct format that each recipient requires. Let's see what new features Data Gateway has to offer. Here in Data Gateway, we find Diffusion's configuration-only off-the-shelf components for consuming data from, as well as delivering data to, popular third-party systems. In this release, we've included adapters for Kafka and JMS, and included new connectivity options for MQTT. This release of Diffusion introduces a Kafka adapter that makes it easy to integrate your Kafka data feeds with Diffusion. We can use the Kafka adapter to connect Kafka topics to Diffusion topics, and vice versa. Let's take a look at this in action. In this scenario, we have a Kafka topic holding foreign exchange trade information that we need to share via Diffusion. We find the Kafka adapter in the adapters directory. This is the configuration to achieve our goal. These are the Diffusion server details, and these are the Kafka server details. And here we're associating the Kafka topic v6.6 to a Diffusion topic of the same name. And here at the tail for clarity, we state that all Diffusion topics are created with a Kafka path prefix. Let's turn the key and see the results. Now we've started the adapter, let's see the data flowing into Diffusion. There's the topic holding the data from the Kafka adapter. Here we can see the data arriving from Kafka ready for subscription by another Diffusion client. This release of Diffusion also includes a JMS adapter, so you can integrate your JMS endpoints with ease. We can use the JMS adapter to connect JMS topics and queues to Diffusion topics, and vice versa. Let's take a look. In this scenario, we have a JMS topic holding foreign exchange trade information that we need to share via Diffusion. We find the JMS adapter in the adapters directory. This is the configuration to achieve our goal. These are the Diffusion server details, and these are the JMS server details. And here we're associating the ActiveMQ topic v6.data to a Diffusion topic with a similar name. Let's start this up and get that data moving. Now we've started the adapter, let's see the data flowing into Diffusion. Here's the topic holding data from the JMS adapter. Here we can see the data arriving from JMS, ready for subscription by another Diffusion client. Diffusion now includes multi-protocol support with its support for MQTT. Diffusion 6.6 supports MQTT clients natively, without the need of an adapter or extra component. Rather, they connect directly to the Diffusion cluster and communicate with other Diffusion clients via Diffusion's unlimited topic tree. Diffusion and Diffusion Cloud support both TCP and WebSocket transports to accept connections from a broad range of IoT devices. MQTT is a lightweight alternative to the Diffusion client SDKs, useful in circumstances where you cannot dictate the client implementation or where no Diffusion code is allowed on the client. Diffusion supports the latest version of MQTT, with support for older versions coming soon. MQTT clients benefit from transparent interoperability with Diffusion clients. Their operational management is the same as other clients, via the Diffusion console, Prometheus, or JMX. MQTT clients can be measured with Diffusion's session and topic metrics, the same as other sessions. Diffusion's rich security framework applies to MQTT clients, giving you fine-grained and dynamic control over the topics to which your clients can publish and subscribe. All connections can be optionally secured with the latest version of TLS, version 1.3. MQTT clients can publish and subscribe via topic views, giving them full access to Diffusion's data wrangling features. Find more detail about Diffusion's MQTT support here. Data wrangling focuses on modeling, translating, enriching, and filtering your event data while it's in flight to its destination. You can also dynamically modify the topic tree structure using the SDKs or via the management console. Topic views can now preserve the topics produced from prior values of a topic using the Preserve Values clause. By default, reference topics produced from a topic view will be removed if the data from which they derive their topic path changes. This applies to both scalar and expand directives. For example, this topic view uses a scalar directive to build out the reference topic, the pair property dictating the path of the reference topic. When the source topic is updated and the pair property changes, a new topic is created and the previous reference topic is removed. From version 6.6 onward, the Preserve Values clause leaves prior reference topics intact, ideal in circumstances where a topic contains information relevant to many subjects, and it must be broken out into subject-focused topics. Let's have a look at this in action. Here is a single JSON topic called FX. It holds foreign exchange data. Let's subscribe to it and see how it changes. It holds a JSON object, and we can see it flickering as the market trade information is delivered. Notice that the name property is not static because this topic is a conflation of trade information for many currency pairs. We need to update that and build out a set of discrete topics, one for each currency pair. Let's do that now with a topic view. We're going to classify the FX feed by its name property. This puts the reference topics underneath their source topic, using the value of the name property for the topic path. And preserve topics means that reference topics are preserved, even if the source topic that created them changes. Now when we look at the topic tree, we see the new reference topics, each of them dedicated to a specific currency pair. Topic inserts give us new capabilities to enrich your event data. And using topic views to reshape or enrich your data on the server can minimize changes to your client applications. Using the topic insert feature, you can now insert data from another topic into a JSON topic when the source changes. Let's build an example where we insert textual analysis into foreign exchange price data. This is the now familiar foreign exchange data. And over here we have analysis on each of the currency pairs. We're going to build a topic view that merges currency analysis text into the foreign exchange topics when the foreign exchange topics change. This will map everything starting with FX to FX-enriched. And this inserts the value of the matching analysis topic into a new object property in the reference topic called analysis. And there's the new analysis attribute. This railroad diagram for the insert feature shows its flexibility. You can specify a piece of the data to insert into the reference topic using the key keyword and a JSON pointer. In the live example, we saw how we use the @ keyword with a JSON pointer to make the insertion. And finally, we can insert a default piece of data if the insertion is not possible. Diffusion 6.6 includes 3 new time series features. API updates to ease the publishing of time series data, API updates to assist publishing of existing time series data, and you can now visualize time series data right in the Diffusion console. You can now update a time series topic using the same update stream API as is used to update other topic types. To append data to a time series topic, use to mandate the use of the time series API. From version 6.6, the developer can update a time series topic as they would a non-time series topic using the update stream. In the broadest terms, updatestream.set now equates to timeseries.append when addressing a time series topic. This means that upgrading to time series topics does not mean changing your code. However, there are further functional and performance improvements too. Update streams calculate topic value changes in the client, making less work for the server and makes the update transmission more efficient. Update streams can enforce constraints when updating or creating the topic. A developer can give the update stream constraints to go ahead only if the topic doesn't exist, or the topic does exist and holds a specific value, or the topic holds a partially matching JSON value, or the session updating the topic holds a session log. So there's lots of flexibility here. Using some of the update stream features, this code atomically checks that JSON topic myTimeSeries data exists and contains at least a field called state that's holding string value live, and it returns a topic stream if so. It goes on to set the topic 3 times to a JSON value. You will notice how field state does not change, which means that when the delta is calculated, only the value field is transmitted. Let's run this. It's failed and logged that the update constraint has not been met. Like the error says, there's no state field in there. Let's set that straight. Let's rerun that. It's worked. Let's see the result. As this is a time series topic, we can see the depth of historic values as well as the current value. So, using an update stream to append events to a time series topic offers both performance and functional advantages. Additionally, if you are only occasionally updating topics, topicupdate.set will also transparently append events to a time series topic. You can now append historic data to a time series topic. Previously, the timestamp of a new time series event was decided by the Diffusion server. Using Diffusion 6.6, we can append timestamped events to a time series topic, providing they are in time order. This is ideal if you wish to publish information from an existing time series source, for publishing historic time series data, or for test scenarios where the fidelity of an event is important. Let's look at the code. This small script loads 13 megabytes of financial data, which covers about 4 hours of foreign exchange prices for 10 currencies. Each price is an individual JSON record on a single line of text. Lines 1 to 4 load the libraries we need, all of which we can install from npm. On line 9, we establish the type of the topic to create for each foreign exchange pair. On line 14, we create an async function because we're going to use async features from both Diffusion and readline. Here we check for at least one argument, the name of the file holding the foreign exchange data. And here we build the machinery to read one line at a time. On line 25, we connect a session to our Diffusion server. And here on line 37, we iterate through each of the lines read from the file. We pass the JSON data into an object. Let's take a quick aside to look at the shape of the data. See how each row carries a field called name, as well as a field called TM, which holds the timestamp of the trade in milliseconds. Both of these will be useful in this example. On line 39, we use the name field to compose the related topic path. Remember that you can use any Unicode character on your topic paths. A topic must exist before we append to it, so on lines 41 to 45, we create any topics we need on demand. If the topic does exist and has the same type, this has no effect, so it's safe to call on existing topics. Then to the star of the show. Here on line 47, we call timeseries.append, which now takes an optional timestamp argument, and here we give it the value of the TM field from the foreign exchange data. Let's run this to create the time series topics holding historic content. Let's have a look at the results of that. Here we are in the Diffusion console, and here is the topic tree that was just created with the time series foreign exchange data. And here below are the historic events, where each has a timestamp in the past. We can now visualize numeric data stored in a time series topic. Time series topics are a good fit for storing financial and other numeric data which changes over time. Let's revisit our foreign exchange code and evolve it to store the bid and offer values in separate topics. This code is much the same as before. However, instead of creating a single JSON topic, it also creates separate numeric time series topics for the bid and offer values. Here on line 41, there's a new function to assist when a new topic is created. And down here, we put it to work, creating 3 topics for each currency pair that is processed. This line is essentially unchanged, whereas on lines 62 and 63, we append the numeric bid and offer values to their topics. Let's try that out and see the result. Let's jump over to the console to see the results. We shall use the topic browser to explore the new time series topics. The console displays this chart for all numeric time series topics, and by default shows the last 10 events. Let's change that to the prior 10 hours. Showing the data here in the browser makes it easier to spot patterns and trends. The data distribution components comprise the familiar Diffusion SDKs that we know and use to achieve massively scalable distribution of data around the globe in milliseconds. This release includes a new SDK as well as improvements to a favorite. Diffusion's JavaScript client is the most frequently used by far. It is a rich client, including all of the management features that you need to build out your solution backend using Node.js. In version 6.6, we have introduced a modular JavaScript client so that you can choose which features to download and minimize load times for your browser clients. The prior uncompressed version is 518K, but version 6.6 brings it down to 341K, and that's a saving of 34%. And this is before we consider compression and browser-side caching. Diffusion 6.6 includes a preview of Diffusion's new Python client. Introducing the first of a growing set of features, we can use this preview release of the Python client to subscribe to topics as well as send and receive messages. Let us know which features you want to see in it next. Let's see it in action. The Python client is available right now in PyPI, so we can download it with pip. Let's put this code to work and subscribe to and display some topics. Let's see it working first. There. We can see it printing brightly formatted foreign exchange data as it's received from Diffusion topics. Let's walk through that code. At lines 1 to 8, we find the shebang line and the library imports. Here we establish our constants, the Diffusion server location and credentials, as well as the topic selector. These functions handle topic events, starting with the first one, onUpdate. This has delivered the new topic values and renders it as syntax highlighted JSON. The other two handle subscription and unsubscription events. We create this async function to accommodate the async calls made to the Diffusion client. This connects our session to the Diffusion server and gets access to the topic feature, which we shall use shortly. This creates the value stream. Its job is to receive incoming JSON topic updates and dispatch them to the handler functions which we saw earlier. And here we instruct the Diffusion server to subscribe us to the foreign exchange topics. That's only 45 lines of pretty legible and Pythonic code. And finally, the Diffusion console, spanning all three categories, now has a gorgeous new look and feel that we think you'll love. The console now supports single sign-on, and also boasts a view of all servers and registered adapters in your Diffusion cluster. Clicking on the adapter, we can see its status and current configuration, and right now this is supported by the JMS and Kafka adapters. Read more about it at pushtechnology.com/blog. That's all for version 6.6. Diffusion 6.6 is available for download immediately and will soon be available in Diffusion Cloud. Check our YouTube channel and GitHub repositories for tutorials and example code. Check back in a few months for the first preview of version 6.7.